Right, welcome everybody to ACT Science with Mr. Tui. I've been meaning to get around to the ACT Science section for so long. I got some ACT math and English videos. Just haven't done science yet, but Maddie reached out to me. Say hi to everybody, please, Maddie.
Hi.
Yeah, and she wants some help with the ACT Science. I'm like, hey, I've been meaning to do a video on it for a long, like years. It's really sad, actually. But anyway, here we are today. We're doing it better late than never. So we're going to focus on ACT Science. Couple things about what I have planned for today. The first thing we're going to do is we're going to talk about just approaching the questions the right way, okay? And you gotta slow down, just do it the right way first. I know one of the things about the science section, I think for many students, they have trouble finishing in time, and I can totally relate because as a student, I took the ACT twice. I still remember I did well enough on it, but neither time did I finish the science section. Neither time. So it's tough to finish in time. There's a little art to it. We'll talk about that. But we also have to talk about just approaching the questions the right way and also increasing your accuracy. So we're going to kind of do both today. Does that make sense so far, Maddie?
Mm-hmm.
Okay, great. So you got an ACT Science test on your end. I've got mine as well, the same one. So let's jump into it and talk about it. So first, the ACT Science, they give you 35 minutes. 35 minutes to answer 40 questions. So that's less than a minute per question. Do you see that?
Mm-hmm.
Oh, it is fast and furious. And I got to tell you, like this, of all the sections students struggle with, it's the science section they struggle with the most by far, and like I said, I can relate from my own experience as well. Okay, so here's the general strategy when you're approaching the ACT Science on if you're taking the test soon or if you're practicing timed work, which we'll get to. We'll talk about that in more detail coming up. But here's how you've got to approach it. You've got to get to the questions as fast as you can. You really do. I don't recommend starting with the questions. I've kind of played with that at times. I recommend reading the passage just at a very good pace. Like read through it, not to understand everything, because the ideas here it's just too complicated to wrap your head around absolutely every idea, and to even look at the charts. Don't even bother with the charts. Just read through it to orient yourself to the ideas in the passage to find out where the information is. You're just finding out where stuff is. Not trying to understand everything, just find where the information is. Does that make sense, Maddie?
Yes.
Yes, because you got to get to the questions as fast as you can. Once you get to the questions, the answers to all the questions are in the passages or in the charts, essentially. There's a couple exceptions to that. But essentially every question, the evidence is there. So then you're going to go back to the passages and the charts and find the evidence there. That's when you can read a little more carefully, read a little more closely, really understand the ideas when you're going back. But to start, and it should take just about 1 minute, no more. If you're taking more than a minute reading the passages, you're taking too much time. I'm serious. Yes. You're just going to read it to orient yourself, get to the questions as fast as you can, and then go back and take your time looking for the evidence because the evidence is all there. Does that make some sense? That strategy, Matt?
Yes.
Okay, good. Now, so we're going to do this right now. I actually do want to read this together, and I want you to read it out loud. But be aware, if you're doing this timed work on your own, you should be going through this passage at a probably faster pace. Right now, I just want you to read it just for the sake of the video. But read it right now, and don't worry if the ideas just kind of go over your head. That's totally okay. It's going to make more sense when we go back and answer the questions.
Okay.
All right.
Researchers studied how diet and the ability to smell food can affect the lifespan of normal fruit flies, strain N, and fruit flies unable to detect many odors, strain X.
Great. Keep reading.
Study 1. 3 tubes 1 to 3, each with 15% sugar yeast, SY medium, a diet with 15% sugar and 15% killed yeast, were prepared. Then 200 virgin female strain N fruit flies, less than 24 hours old, were added to each tube. No additional substance was added to tube 1. Additional odors from live yeast were added to tube 2, and live yeast was added to tube 3. The percent of fruit flies alive was determined at every 5 days for 75 days.
Okay, I'm going to stop you real quick. I guess if you're anything like me, that information just kind of goes over your head. Is that roughly your experience there? There's like so much information. Yeah, right? And this all you do, you're reading it, and again, you're scanning through it on your own, on the actual test. But you're reading, be like, okay, they're talking about, like, we got some different tubes with some different, like, percentages of stuff going on here. Okay, great. And that's study 1, right? We got some fruit flies, some 15%, sugar yeast medium, whatever. Okay, great. And so if they ask about study 1, you know where that is, you know kind of the generally information that's there. That's it. Okay, don't even worry about understanding it right now. Go and read study 2.
3 tubes, tubes 4 to 6, each with 5% SY medium, a diet with 5% sugar and 5% killed yeast were prepared. Then 200 virgin female strain and fruit flies less than 24 hours old were added to each tube. No additional substance was added to tube 4. Additional odors from live yeast were added to tube 5, and live yeast was added to tube 6. The percent of fruit flies alive was determined every 5 days for 75 days.
Okay, great. And they give us a bunch of charts. Don't even worry about the charts. Don't even look at the charts until they ask you a question about them. We'll come and look at them a little bit later. Go ahead and read study 3.
Strain N fruit flies were modified to produce strain X fruit flies. Strain X fruit flies lack OR83B, a protein required to detect a wide range of odors. Therefore, they cannot detect many odors. The average lifespan was determined for virgin female strain N and virgin female strain X fruit flies fed with various SY media.
Okay. Once again, so much information here, but roughly, here's the outline, right? We've got study 1, right? We got the fruit flies and it looks like 15% SY medium here. And that one. Study 2 sounds pretty similar, except it's 5% SY medium. So a different sugar yeast percentage. Does that make sense?
Yes.
And then study 3's got something going on with these fruit flies that don't have the ability to detect odor. All right. We've genetically modified them. Yay, science. All right, fun. Does that make sense?
Yes.
That's good enough. Now jump into the questions. And again, that should take you about a minute just to scan through that information and orient yourself to where the information is. That's it. Okay. Now, go ahead and read question number 1. You should see it on the screen share. Read it out loud. We'll answer it together.
In which of studies 1 and 2 did some of the fruit flies live for more than 75 days? And what diet were those fruit flies fed?
Okay, you're going to have to go back to the information in the passage in the chart to answer this. Is that clear? It's not something you're going to just absorb and memorize through your own reading, right, on that initial read. You got to go back. So let's go back. So some of the fruit flies live for more than 75 days. Let's go back to study 1 and 2. And
I just realized I was pronouncing. I said live instead of live.
Oh yeah, we're good. I didn't even notice. Didn't even notice. All right, so look at the chart here, right? I think I see where the fruit flies are living for more than 75 days. Do you see it, or no?
Are we in?
It says in study 1 and study 2, and there's only one part of the chart where it talks about how many days have passed.
So, chart 2.
Probably chart 2. Yeah, in study 2. Do you see that? Yeah, because they're living longer there. Is that clear?
Yes.
All right. And then what SY medium were they fed? Do you see which one it is? It's all the ones down here have died, right? At the very bottom. But this guy is alive. Looks like some of them survived. So what SY medium were they fed?
Just the 5% SY medium.
Done. That should be the answer. Let's go back to the answer choices. So we know it's study 2, right? Because all of them died in study 1. Is that clear? Yeah. So study 2. What's the answer?
C.
It's C. Done. Do you see why it's useless to take a ton of time reading and trying to understand all that it is and analyze the charts and all that stuff? Because you don't even know. There's so much information. It's what do you focus on? That's why you get to the questions as fast as you can, so you can figure out what information you're looking for. Does that make sense?
I see. Yes.
Great. Again, 1 minute read, just to orient yourself, get to those questions as fast as you can, find the evidence in the answer choices. And that's the process. Okay? Go and read question number 2.
During studies 1 and 2, why did the size of the fruit fly population in each tube decrease rather than increase?
Okay. Do you know right now why the size of the fruit fly populations decreased rather than increased? Do you have any idea? You might be able to answer. If you don't know right now, we can test the answer choices.
I don't know.
Yeah, okay, then if you're not sure what the answer is, and you don't know where the answer is, then we test answer choices. Okay, so go ahead and read answer choice F.
The birth rate was 0 because the initial population contained only males.
Okay, was the birth rate 0 because the initial population contained only males?
There were no males.
There were no males. You see that? It says 200 virgin female strain N fruit flies were added each tube. That's in study 1. And I think in study 2 as well, same thing. 200 version straight N fruit flies were added to that one too. Does that make sense?
Yeah.
So they're all females. Okay. Well, we can get rid of some answer choices now, right? Like answer choice F is saying there were males. I think answer choice H says there's males there as well. Do you see that? There's no males. Is it G or is it J?
Because the initial population contained only virgin males. Because the initial
Do you see the difference between G and J? Do you see the difference? They're slightly different.
Death rate and the birth rate.
Death rate and birth. Yeah, G says the birth rate was 0 because it was only virgin females. J says the death rate was 0 because the initial population contained only virgin females. Well, was it the birth rate that was 0 or the death rate that was 0?
Can I look at the chart again?
Yeah. I mean, if any of them are dying, then the death rate's not 0.
Oh.
Right? Are they dying?
Yes. No. But they are dying.
Yeah, they're dying. The death rate's not 0, right? But if it's all females, they aren't giving birth. Does that make sense?
Yes.
So it's got to be G. That's the answer. Does that make sense?
Yes.
Once you got to go back. So, like, if you know what the answer is, sometimes you answer it on your own, right? I generally recommend going back to make sure you get the evidence. But if you're not sure about where the answer is, in the passage or in the charts, then start testing answer choices like we did. And we could be like, oh, there's no males. Okay, so it's got to be G or J. And then, once you saw the difference there between them, the death rate definitely wasn't 0. It's got to be G, and it is. Does that make sense?
Yes.
Yeah. And what was the answer to number 1 as well? I think that was study 2, 5%.
Yeah, study 2,
right?
C.
Yeah, C. Okay, great. I just want to clarify that on the screen share. Okay, great. Go to read question number 3.
Study 1 differ from study 2 in which of the following ways?
You might be able to answer that right now. How did study 1 differ from study 2?
Well, the percent.
Yeah.
The percentage.
Yeah, the percentage of the SY medium. Do you see that? Study 1 was 15%, study 2 is 5%. Okay, great. Go back. Whoa, too far ahead. Go back to the answer choices. I think you already found the answer. Or at least we can narrow it down.
C or D.
It's either C or D, right? Now, C says the SY medium tested in study 1 contained a lower percentage of sugar than the SY medium in study 2. Is that true?
It should be D.
It should be D. It's the other way around. Yeah, study 1 had a higher percentage because study 1 was 15%. Do you see that? Great. The answers are all there. Is that clear? Yeah. You just got to go back and find it. Is this similar to how you've been answering, working on the science section so far, or is this a little bit different?
This is pretty similar.
Yeah. Okay.
But, yeah.
What's the difference between what we're doing now and how you've been approaching it?
Well, it's just that, I just keep on having to go back and forth.
And that's okay.
And it, wastes a lot of time.
Yeah, and that's okay. You have to. You have to go back and forth. There's no way around it. But you just got to, accept that fact that you're going to be going back and forth.
Yeah.
You're not going to get it on that first read. So that's why you've got to get to the questions as fast as you can. And then you go back and forth, and that's okay. And it's easier in a booklet, right? Because you're kind of you can flip pages pretty quickly, I think. But that's the process. That's the process. And here's the deal, too. Is as long as you're not getting stuck on the toughest questions, you're going to finish in time. If you read a question and, you have no idea what it's asking you and, over a minute it's ticked by, just slap down an answer and move on. You know what I'm saying? That's essentially how you deal with timed work. You're going to finish in time as long as you don't get stuck on the toughest questions. That's how you deal with it. Does that make some sense?
Yeah.
You got to have a little bit of an internal clock going on. But you got to practice just answering the questions the right way first, the way we're doing it right now. Go ahead and read question number 4 for us, please.
Suppose that an additional trial in study 3 had been performed using a 12% SY medium, a diet with 12% sugar and 12% killed yeast. The average lifespan of the strain X fruit flies in this trial would most likely have been...
Okay, now we're talking about study 3. Okay. And what are they asking us here about study 3? What's the question here?
If it had 12% SY medium, what's the average lifespan?
What would the average lifespan be if there's 12% SY medium? Okay.
Would it be...
Yeah, let's look at the chart. I mean, do you see where they tell us what the SY medium is? Do you see where that is?
Mhm.
Yeah, it's like right here in the middle. And then they give us the lifespan for each SY medium. Okay? But they're asking us for an SY medium of 12%. I don't see 12% on there. But I see some numbers
It would
around
be
it, right? Yeah.
it would be between 58 and 55.
Yeah, it's got to be right because they're asking for strain X, I think, right? Yes, they are asking for strain X. So it's got to be right somewhere between here. Does that make sense? What's the answer?
Oh, between 58 and 50.
Yeah.
Yeah, 50 and 55. So G.
So G. It's G. Absolutely. Does that make sense?
Mm-hmm.
Yeah. That's it. That's not bad. It's right there. You got to find it. Takes a little time. But it's there.
Yeah, that was an easier one.
It's not bad. Yeah. And you'll see the difficulty level really does vary. Some is like, bingo, bango, got it. You know. And some is like, oh, man. And that's okay. Just don't get stuck on those really, really tough questions. That's okay. Get the ones you should be getting right. So don't rush them. But we'll see some tougher ones coming up for sure. Go to read question number 5.
The researchers had predicted that decreasing a fruit fly's ability to detect odors would increase its lifespan. Are the results of study 3 consistent with this prediction?
Okay. Great. Ooh, what is the question asking us here?
If they decrease the fruit fly's ability to detect odors, and if it would increase its lifespan.
Yes. Yeah. So are the results from study 3 consistent with that prediction? Okay. Well, let's look at study 3. And they do talk about reducing or decreasing a fruit fly's ability to detect odors. Which strain did they reduce the ability to detect odors in? Which strain?
Strain X.
Strain X. They tell us that right there in the introduction. You see that?
Mm-hmm.
Yeah. So did that increase their lifespan?
It did.
It did. So far we can get rid of A and B, right? Because A and B say no, it's not consistent. So far it's consistent, right? Does that make sense? A and B are gone. Love elimination, by the way. Love it. It's either C or D. Let's test C. Go and read answer choice C.
Yes, for each SY medium tested, the average lifespan of strain X fruit flies was longer than the average lifespan of strain N fruit flies.
Okay. Is that a true statement?
That's true.
I think that's true. Go and read D real quick. I'm going to double check D.
Yes, for each SY medium tested, the average lifespan of strain N fruit flies was longer than the average lifespan of strain X fruit flies.
Is that a true statement?
So that's wrong.
Yeah, it's wrong. Yeah, it's got to be C. And it is. Not too bad. Questions about that?
Nope.
All right, let's keep rolling. Number 6.
Suppose the researchers wanted to determine whether a defect in the ability to detect odors would change the lifespan of fruit flies fed a 15% SY medium when live yeast is added to the diet or when additional odors from live yeast are added to the diet. Which of the following experiments should be performed?
Whoa. Do you understand this question or not so much?
If the odors would change the lifespan of fruit flies. Something about odors.
Yeah. Notice at the very beginning, right? They're saying, suppose researchers want to determine whether a defect in the ability to detect odors would change the lifespan of fruit flies fed 15% SY medium.
Okay, and if live yeast is added to the diet?
Yes.
Or an additional odors?
So we're talking about whether or not, look at the answer choice real quick, whether or not we're repeating study 1 or study 2, and then which strain of fruit flies we need. Does that make sense? So we can figure out which study, right? Which study is using 15% SY medium? Is that 1 or 2? I got to go back.
1.
Yeah, that's 1. So just knowing that, we can get rid of some answer choices. We can get rid of H and J. Does that make sense? Love elimination on this test. Get rid of the obviously incorrect ones. Now, F and G are left, and one of them says we're using strain X. One of them says we're using strain N. Which strain are we using? X or N?
Should be X.
Should be X, right? Because that's the one that's been modified to get rid of its ability to detect odors. And it's F. Does that make sense?
Yeah, that was nice.
That's not too bad. Right? It's not too bad. Just step by step there. Just step by step, right? But you've got to really understand the question. And it's funny because when you read that the first time, it was like, it just went over my head. It really did. There's so much information. It's in the passage and the charts, but sometimes even in the questions. And if you got to reread it, if you got to read it 2 or 3 times, that's always a good investment of time. Always. Because if you don't understand the question, it doesn't matter what you do. You're wasting your time if you don't understand the question. Now, if you've read it 2 or 3 times and you still have no idea what's going on, great, skip it and move on. Okay? But read through it again if you didn't understand it the first time. It's there. It's all there. Any questions about that?
Nope.
Go and read question number 7 for us, please.
The results for which 2 tubes should be compared to determine how a reduced calorie diet affects lifespan in the absence of live yeast and additional odors from live yeast.
Whoa. Do you understand this question or no? Yeah. Which
The
tubes?
results of which 2 tubes.
Yeah. And we need tubes, let's see, that are how reduced calorie diet affects the lifespan in the absence of live yeast and additional odors. Okay, so which tubes basically have an absence of live yeast and additional odors? Well, let's go back to study 1, study 2. Which tubes?
It's the squared ones.
Yes, but that doesn't tell us the tube. It tells us the tube number in the passage.
Two and tube 3.
Well, see, so it says additional odors from yeast were added to tube 2. Do you see that? And live yeast was added to tube 3. So those have either additional, right? We need the absence. Do you see that? We need the absence, I think, right? Because we're trying to figure out how reduced calorie diet affects the lifespan in the absence of live yeast and additional odors from live yeast. Does that make sense? So we need the one that doesn't have anything. So I don't think it's the square ones, actually, looking back at it now. Which tubes? Look at the passage. It tells us which tube doesn't have any additional odors or live yeast.
Tube 1?
Tube 1. Do you see that? So it's got to have tube 1 in study 1. Which tube in study 2?
It's not tube 5 or tube 6.
No. So
tube 4.
It's got to be tube 4, right? It says no additional substance was added to tube 4. There's got to be tubes 1 and 4. Does that make sense? We should be able to find the right answer. Booyah. Answer choice A.
I felt like in that instance, like it took me a while to see.
Yes, but I think the issue...
Because it actually took me a while to see the tube 4. Like I didn't like read it again or anything.
Yeah. Well, there were 2 things there. One was just, I think, understanding the question, right? Because you saw live yeast and additional odors, and I think you gravitated towards the tubes that had live yeast. And
not the absence.
Right? Yeah. But the question saying, no, we need the absence of live yeast and additional odors. And then you just got to find out which ones don't have live yeast and additional odors, and it was 1 and 4. So it's understanding the question, right? And then, but you got to read really carefully when you go back as well. Do you see that? And that's why that initial read just doesn't matter too much. Like there is no way I could answer, even if I spent like 5 minutes reading the passage and studying the charts. There's no way I could answer these questions without going back. Is that clear? Like maybe I could do like number 2. Maybe.
Yeah.
But like the rest of I'm not finding the answers unless I go back. So just accept the fact that you're going to go back. You're going to find the answers. They're there. And just get to those questions as fast as you can. And read the questions super carefully. And go back and read the passages and study the charts really carefully. You've got time to do it if you're not getting stuck on the tough ones. Questions about this or not so much?
Nope.
And that's it for the first passage. Let's do the second one. Okay. Now this guy here, there's a little bit more reading here. A little bit more reading. Okay. Go and read passage 2. Read passage 2. And we'll jump into the question.
Fall, monarch butterflies.
Don't even worry about proper names here. You know what I'm saying? Like these sites. Don't even worry about DP, or you can just skip it, honestly.
In eastern North America, migrate to Mexico, where they overwinter in high altitude forests of OS.
Yeah, great.
And evergreen conifer. The butterflies store accumulate body lipids to use as a source of energy at a later time. Consider the following 3 hypotheses pertaining to when the butterflies store lipids and when the energy from the stored lipids is used. with respect to migration and overwintering.
Oh, let's read them together. Go ahead and read hypothesis 1.
Monarch butterflies require energy from stored lipids for migration and during the overwintering period. The butterflies first store lipids before they begin their migration. During migration, as stored lipids are converted to energy, lipid mass continuously decreases. When the butterflies reach the overwintering sites, ending their migration, they must store lipids again before beginning the overwintering period.
Great. Go ahead and read hypothesis 2.
Monarch butterflies require energy from stored lipids for migration, but not during the overwintering period. The butterflies store lipids before they begin their migration. During migration, as stored lipids are converted to energy, lipid mass continuously decreases. Because energy from stored lipids is not required during the overwintering period, the butterflies do not store lipids while at the overwintering sites.
All right, number 3.
Monarch butterflies require energy from stored lipids during the overwintering period, but not for migration. The butterflies do not store lipids before they begin their migration. Instead, lipids are stored during migration. Therefore, lipid mass continuously increases from the beginning of migration until the end of migration. The butterflies arrive at the overwintering sites with enough lipids to provide themselves with energy during the overwintering period. So they do not store lipids while at the overwintering sites.
Okay. I think that's it. That is it. So much information there. Like, I can't even process it. It goes over my head. All right.
Yeah, I mean, is that they're all very similar.
Yeah, they're so similar. Right? But I know, like, okay, there's 3 hypotheses and there's some differences here. We'll find those differences. But don't worry about understanding everything right now. It's just like, okay, that's where the information is. We got these 3 hypotheses and there's just different dynamics with each hypothesis. That's it. Okay, great. Go ahead and read question number 8.
Which hypothesis, if any, asserts that monarch butterflies store lipids during 2 distinct periods?
Okay, now we're going back and we know what we're looking for. We're looking for the hypothesis, if any, that asserts that the monarch butterflies store lipids during 2 distinct periods. Let's start with hypothesis 1. Does that assert that monarch butterflies store lipids during 2 distinct periods?
They do it before they begin the migration, and they store again before the beginning of their overwintering period.
It looks like they do, right? In hypothesis 1, is that clear?
Mm-hmm. Yeah.
Okay. Look at the other answer choices. Look at them. What's the answer here for number 8?
It's F.
It's got to be F, right?
Yeah.
Right? Thank God, right? We didn't have to read them all. We didn't, right? But be aware of that, right? That like, okay, we found the information we needed. It works for hypothesis 1. And if hypothesis 1 does have 2 distinct periods, which it does, then it can't be G, it can't be H, and it can't be J.
Mm-hmm. I feel like in this instance, I would literally waste time checking.
Yes, but you see, strategic, right? Just kind of previewing the answer choices a little bit will save you a ton of time. You don't have to test the others once we have our answer in this case. Now, if like the other answer choices said like 1, 2, and 3, okay, then you got to read them all, or 1 and 2, or 1 and 3, right? And sometimes they do that. Mm-hmm. But here we can stop. That's F. Does that make sense?
Mm-hmm.
Great. Go and read question number 9.
Which hypothesis, if any, assert that monarch butterflies require energy from stored lipids neither for migration nor during the overwintering period?
Okay. All right. Let's test. So do you understand this question here?
Mm-hmm. Right. If they require the stored energy of lipids.
Yeah. For neither migration nor overwintering. Mm-hmm. Okay. Let's start with hypothesis 1. Does that do they require stored lipids for neither migration or overwintering?
They don't. Or will they?
It says the butterflies first store lipids before they begin their migration. I'm looking at hypothesis 1. During migration, as stored lipids are converted to energy, lipid mass decreases. It sounds like they need them for migration there. Does that make sense?
Yes.
Yeah, and then it says when the butterflies reach their overwintering sites, ending their migration, they must store lipids again before beginning overwintering. So what do you think about hypothesis 1?
Oh, that's not correct.
That's not correct, right? Because the question says, which one says they require energy from stored lipids neither for migration nor overwintering? I think hypothesis 1 is saying they need it for both. Is that clear?
Mm-hmm. Yes.
Okay. All right. Try hypothesis 2.
They don't need it for the overwintering period.
Yeah. Do they need it for migration in hypothesis 2?
It's not required.
For migration?
They need it for
They
migration.
need it for migration. Right there in the first line. Monarch butterflies require energy from stored lipids for migration. Does that make sense?
Mm-hmm.
So it can't be B. Because we're looking for the one that says they don't need it for migration or overwintering. Makes sense?
Mm-hmm.
What about answer choice C, hypothesis 3?
They don't need it for migration, and they do not store lipids at the overwintering sites.
Well, hold on. Read the first sentence in hypothesis 3. I want you to read it out loud.
Monarch butterflies require energy from stored lipids
Yeah.
during the overwintering period, but not for migration.
That's saying they need it for overwintering, but not for migration. But they need it for overwintering. Does that make sense?
Mm-hmm.
So it can't be C, right? Because the question again is saying they need it for neither migration or overwintering. You see the importance there of understanding the question?
Mm-hmm. Oh. I was looking at the last sentence of that.
Ah, gotcha.
So it said, so they do not store lipids while at the overwintering sites.
Yes. Yeah, because it says they pick it up while they're migrating.
Mm.
Yeah.
See, that would get me.
Yeah.
That would get
I get it. But you see why that first sentence makes the point very, very
clear.
Yeah.
Mm-hmm.
Yeah. I got you. I get your confusion there. But that's a little bit of an assumption there. Yeah. It just says they need it. All right. Questions about that or no?
Nope. So it should be D.
It is D. Go and read question number 10.
Based on hypothesis 3, which of the following figures best depicts the change in the lipid mass of monarch butterfly from the beginning of migration to the end of migration?
Ooh, read that note as well. This is important here.
In each figure, B represents the beginning of the migration and E represents the end of the migration.
Yeah. Yeah. Does that make sense?
Mm-hmm.
Okay. So we're just talking about the migration period from beginning to end. Go ahead and scan through hypothesis 3. See if you can find any information about the change in lipid mass of monarchs in hypothesis 3.
Continuously increases from the beginning of the migration until the end of migration.
There it is. Do you see that?
Mm-hmm.
It's continually increasing. And it says they don't store lipids before they begin their migration as well. So that's good enough to find the answer here.
So it should be J.
It's J. I was just going over this test, and I'll just be straight with you. I picked F initially. I've done this test before because it says, what does it say? It says at the end they arrive with enough lipids to provide themselves, so they don't store lipids at the overwintering site. So I was like, oh, so they don't have any at the end. It's kind of high. I focused on the end there as well, right? So like maybe during overwintering it goes down, because they're using the lipids then for overwintering. But the chart is just representing the migration.
Uh-huh.
And it says it continuously increases from the beginning to the end of migration. So it's got to be J. And it is.
Yeah.
Questions about that or no?
Nope.
Okay. Great. Question number 11.
Assume that changes in the body mass of a monarch butterflies are caused only by changes in the mass of the butterfly's stored lipids. The statement, the percent of a monarch butterfly's body mass that is made up of lipids is greater at the beginning of migration than at the end of migration is supported by which of the hypotheses?
Ooh. Okay. Do you understand this question here or no?
Mm-hmm. That the percent of a monarch butterfly's body mass that is made up of lipids is greater at the beginning of migration than at the end.
Yeah. It's got more mass made up of lipids at the beginning of migration than at the end of migration. Does that make sense?
Mm-hmm.
Okay, so which hypothesis would support that? Let's go back to the hypotheses. Would hypothesis 1 support that?
They must store lipids again. Yeah.
I think it would. Why?
Because then that means they have to store lipids again at the end because they had more at the beginning.
Yeah, so they store lipids before they begin their migration. So they got a bunch of lipids. Then during migration, the stored lipids are converted to energy and lipid mass goes down. So they've got more at the beginning than at the end of migration in hypothesis 1. Is that clear?
Mm-hmm.
So that works. So just knowing that, we can get rid of Well, we can get rid of B at the very least, right?
Yeah.
We can get rid of B. Okay, now we got to consider hypothesis 2.
Okay. The monarch butterflies record. Should be yes.
Yeah. Yeah, they've got more at the beginning and at the end. Is that clear?
Yeah.
Because it says their lipid mass continually decreases. I mean, so that means they started with more and then it goes down as it's converted to energy. Does that make sense?
Mm-hmm.
So 2 works. Okay. We got to test 3 now. And it's not A, right? Because it's not just hypothesis 1. Let's test hypothesis 3.
No,
I don't think that's right? Why?
because it continuously increases from the beginning.
Yeah. If we thought clearly, which I think we did about question number 10, right? The one that said represent the relationship between lipid mass and time during migration, right? Like then we if you had that clear in mind, heck, we don't even have to go back. But there it is. So it can't be D. It's got to be C. I'm going to double check. Yeah, 11 is C. Beautiful. Questions about that or no?
Nope.
That's a tough question. It'll take some more time. But if you understand the question, again, all the evidence is there. It's all there. I tell students all the time, if you're playing this game the right way, you're just playing Where's Waldo. You're just finding where you're just finding where the information is, right? Like you don't have to bring in your opinion. Very rarely do you have to bring any outside understanding, although occasionally you do. We'll see one of those questions coming up. But it's just hunting for the information. That's it. Go to read 12.
To store lipids, monarch butterflies convert sugar from nectar they have consumed into lipids. A supporter of which hypothesis, if any, would be likely to claim that to ensure the butterflies can store lipids for overwintering periods, nectar must be present at the butterflies' overwintering sites.
Ooh, do you understand this question or not so much?
The nectar. So, it's converted into sugar.
Okay.
To claim to ensure butterflies can store lipids for the overwintering period, nectar must be present.
Yeah.
At the butterflies' overwintering sites.
Yeah. If nectar has to be present. So if they need to increase their lipids, right, for the overwintering site, then there needs to be nectar there. Does that idea make some sense?
Mm-hmm.
Okay. So for which of the following nectar must be present? Okay. So do we need nectar to be present at hypothesis 1 for the overwintering site for hypothesis 1? We'll go back to it.
I'm not sure how, okay, I'm a bit confused, actually.
Yeah, are you confused by the question? Is it the question?
Yeah.
Yeah. Let's go back to the question. There's no, if you don't understand the question, skip it and move on. Like you're wasting your time. Or I should say, go back and reread the question first.
Mm-hmm.
Read it again. Go ahead and read it again.
To store lipids, monarch butterflies convert sugar from nectar they have consumed into lipids. A supporter of which hypothesis, if any, would likely to claim that to ensure the butterflies can store lipids for overwintering period, nectar must be present at the butterflies' overwintering sites.
Yeah. So if they're increasing their lipids, before they're overwintering, there needs to be nectar present.
Mm-hmm.
So we're just seeing which hypothesis requires them to increase their lipids for overwintering. Does that make sense?
Mm-hmm.
So let's go back to hypothesis 1.
If it needs nectar to increase the lipids?
Exactly, yes.
Well, hypothesis 1, it decreases.
As they migrate, but we're talking about overwintering.
As they migrate.
Yeah.
Overwintering.
Read the last sentence of hypothesis 1.
When the butterflies reach the overwintering sites, ending their migration, they must store lipids again before the beginning overwintering sites.
So do they need nectar there?
They do.
They do. So 1 works so far. Oh, boy. Look at the answer choices.
It's F.
Should be. It is. It is, right? Right? We don't even need to read the others. Praise God. Right? Because of the structure of the answer choices. So look out for that. That'll save you some time. Is that clear now?
That is clear.
Yes. You see the importance of understanding the question. It's always a good investment of time. Always. If you need to read it twice, you need to read it 3 times. But if you still don't understand after the 3rd time, skip it and move on. Okay.
Yeah.
But sometimes you got to read it. I'm that way. Like, I'm not a genius here. I'm not. I'm just a guy that does test prep. But if you got to read, I've got to do it all the time. That's okay. It's there. You just got to think clearly about it and test those answers. All right, go and read 13 for us, please.
Which of the following statements about lipids in monarch butterflies is consistent with all 3 hypotheses?
All right, we're going to have to read these and test these. Go and read answer choice A.
The butterflies' lipid masses do not change during the overwintering period.
Let's test that. Is that consistent with all 3 hypotheses? That the lipid masses don't change? Yeah.
It isn't.
I don't think so. Yeah. Why not?
Well, do not during the overwintering period. And hypothesis 2 and 3 are different for that.
Yeah, and I think if they're using lipids during the overwintering period, then it's going to change. Does that make sense?
Uh-huh.
And I think at least hypothesis 3 is saying they're using lipids during the overwintering period. Right, the butterflies arrive at the overwintering sites with just enough lipids to provide themselves with energy during the overwintering period. So it's going to be going down during the overwintering period, at least for hypothesis 3. So that's not consistent with all of them. That's good enough. Right, we don't have to look at the others. Does that make sense? It's not A. Go and read B.
The butterflies' lipid masses change during migration.
Is that consistent with all 3 hypotheses?
So, hypothesis 1, during migration, they are converted to energy and it decreases.
Okay, so it changes there. What about hypothesis 2?
Are converted to energy and the lipid mass continuously decreases.
Right, so it changes there. What about 3?
Therefore, lipid mass continuously increases from the beginning of migration.
Yeah. Does it change there?
Yes.
Changes there. I think we found our answer. Right?
Yeah,
it's got to be B. I'm not even worried about C and D. And we could test them, but like on a time test, like, hey, we found our answer. I think it's clear evidence for that. Let me double check and make sure. Yeah, it is B. Okay. Well, there it is. There it is. Took a while to test that. It's there.
I feel like that one, it would have made me a bit confused because hypothesis 1 and 2 decreases when hypothesis 3 increases.
Yes, but notice answer choice B doesn't say the butterfly's lipid masses increase.
Yeah, it just
doesn't
changes.
say lipid masses decrease, right? Because that wouldn't be true for all of them. But it does change for all of them. Is that clear?
Yes.
And you struggle to find evidence for C or D, which is another clue. And by the way, like, if you test all the answer choices and like none of them seem to have evidence for it, you misread something. You either misread the question or misread the answer choice. Yeah. Questions about that one or no?
Nope.
Okay. Now 14 is a little bit different. This is the only one so far, and you'll see like 2 of these, maybe 3, on every ACT that require outside understanding.
Okay.
This is one of them. Go read number 14.
When the monarch butterflies use their stored lipids, the lipids must be broken down to produce energy-rich molecules that can be readily used by cells. Which of the following molecules is is produced as a direct result of the breakdown of the lipids.
Oh my goodness. Okay, what do you understand this question or not so much?
Yeah. If it's produced, when it's broken down, it produces energy-rich molecules. So which of them produces that?
Yeah, what's produced with a breakdown of the lipids when those break down? Okay. So this is tricky. I mean, like some students can look at this. Maybe I think when I saw it the first time, I was familiar with each of these terms. You know, I somehow still remember biology class from high school.
Yeah.
How? I have no idea, but I do remember it. So I knew the answer.
Energy.
I knew the answer. Do you think you know the answer here by looking at these?
It should be F, right? ATP.
It is. It is F. It is ATP, right? So great. Like if you have that understanding, if you have that knowledge, fantastic. You got your answer. Okay. But let's say you're not familiar with ATP, but you're familiar with the other stuff, right? You can still focus on what you know, right? Like you've heard of starch. What's starch? What is that?
Starch is like a substance. It's like, I don't know. But I just know that.
What has starch? What has starch?
Like cornstarch.
Yeah, like cornstarch, but like other foods, right, are made up of starches or like chains of starches. Maybe starch is a chain. I think it is a chain, actually. But like starchy foods would be like breads and cereal, like pasta, right?
Yep.
Right? They're carbohydrates. And you're not getting carbohydrates from a breakdown of lipids, right? Lipids are fats. Does that make sense?
Yeah.
So like G doesn't make sense. DNA? Right? You know what DNA is, right? Are you getting DNA from a breakdown of lipids?
No.
No. Amino acids? You're getting amino acids from a breakdown of lipids? Do you know what amino acids are?
Oh, I just know ATP because that was like one of the main, easy vocab.
Yeah.
But amino acids are...
They're like the building blocks of proteins.
Okay.
Yeah.
Okay.
Yeah. I think there might be amino acids in DNA. Is that right? Like the...
I believe so.
CG, cytosine.
Yeah, I took that class last year. It's like coming back to
that whole deal. Anyway, but that's like it has something to do with proteins, not lipids, right? But yeah, ATP is the molecule you get when it's the energy molecule basically. You need that from breakdown lipids. Questions about that?
Yep.
I think you get it from other ways too, but process elimination. Even if you didn't know what ATP was. Whoa, I did too much there. Hold on. There we go. It is F. Okay. I think that's it for that passage. So be aware that occasionally you'll see some of those where you've got to have outside information. And if you just don't know it, just skip it and move on, right? Slap down again. See if you can reasonably eliminate something. But let's do one more passage here. I think you're doing great, by the way. Go and read passage 3.
Okay. Greenhouse gases such as methane warm Earth's climate. Figure 1 shows the concentration of CH4 in Earth's atmosphere and the solar radiation intensity at Earth's surface for tropical Europe and Asia over the past 250,000 years. As the figure shows, the CH4 concentration and the solar radiation intensity have increased and decreased at the same times over most of this period. Figure 2 shows the same types of data for the same region over the past 11,000 years. This figure is consistent with the hypothesis that the greenhouse gases from human activities may have begun warming Earth's climate thousands of years earlier than once thought.
Oh, yeah. Okay. All right. That whole idea. Okay, great. Okay, great. And there's a chart. There's lots of information here. I think we got some more charts. Oh, and more charts. Oh, fun. Okay, right. Don't even worry about them. Don't even worry about them. Okay. We'll focus on them when we read the questions that relate to them. Go ahead and read question number 17. Oh, no. Go and read question number 15. Yeah.
According to figure 2, the solar radiation intensity 8,000 years ago was closest to which of the following?
Okay, great. Let's go to figure 2. So we're looking for the solar radiation intensity 8,000 years ago. This is figure 2. Do you see it? Okay, a lot of information here. Let's talk about some graph analysis real quick, because I think this is going to be helpful here to answer this question. When you see a graph, the temptation is to start looking at like the data points on the graph. Right. And that's just where my mind goes. I look at the data points and I see like some trends or something like that. But then I realize I have no idea what I'm looking at. I don't know what any of this means. So you got to like studying everything around the data. So just start there with the stuff around it. Look for a title. If you see a title, there's no title here. Study the y-axis going up and down. There's 2 of them here. What's the y-axis going up and down?
Concentration of methane in Earth's atmosphere and the solar radiation
and that's
intensity.
On the right-hand side, right? And then the left-hand side is what?
The solar intensity.
Yeah, solar radiation intensity. I think that's what they're asking about, right, for this question? Yeah, solar radiation. So we're worried about the one on the left-hand side. What's the x-axis going left and right?
Thousands of years ago. We're looking for 8,000.
Yeah. And notice the units. The units are so funky, right? Because they're starting with 10,000. I guess that makes sense, right? Because that'd be farther in the past, right? Left to right. But you're starting with 10, right? It's still a little bit funky. And we're talking about 8,000 years ago, I think.
Yes.
We're talking about. Yeah, okay, great. Notice there's a key here as well. You got to study the key.
Oh.
Yeah, do you see it?
Mm-hmm.
And we're talking about solar radiation here. So that's the dotted line. The CH4 concentration is the solid black line. Does that make sense? So where's 8,000 years ago on this chart? Do you see it?
It should be, the solar radiation should be like about a little less than 500.
Yeah, right around 500, right? Because you got to go like 2 spaces to the right of the 10. That'd be 8,000 years ago. Then find it right there on the dot. That's right around 500.
Or it is 500.
Maybe. Look at the answer choice.
Maybe.
Oh.
Oh.
Yeah. Now, they're all kind of like close if you look at the answer choices. But go back to the chart. Do you see like how dramatically different like 5 units for this solar radiation is?
Yeah.
Yeah. I mean, it's got the only one that's close is 500.
So it should be 500.
Should be C. Let me double check. Yeah, 15 is C. Absolutely. Does that make sense? Do that graph analysis problem. If you got to study a graph closely, do that. Look for a title. If there's a title. Study the axes and the units, by the way. Study the units as well. Sometimes the units are not intuitive. Look for a key if there's a key. And then lastly, look at the data. Because it's only going to make sense if you understand the stuff around it. Does that make sense?
Yes.
And I get like I still do it if I see a chart or a graph and like I'm on Twitter or X or whatever, or like even on these tests, like I still gravitate towards the data points and I'm like, wait, I don't know what I'm looking at, right? Like start with the stuff around it. Lastly, look at the data. That'll increase the speed and the accuracy of your graph analysis. Go through that process. Make sense?
Yes.
Great. Question number 16.
According to figure 2, if the trend in the methane concentration had continued to match the trend in the solar radiation intensity, the methane concentration at present would most likely be.
Ooh, do you understand this question or not so much?
We're comparing the concentration, the solar radiation and the concentration.
Yeah, if the CH4 concentration continued to match the trend in solar radiation, I think that was the dotted line, right? So if the CH4 continued to match that trend in solar radiation, and the question is, to match the solar radiation, the CH4 concentration at present would most likely be what? Okay? You see it now?
What is present?
Do you see where present is in
figure 2? I do.
You see it? So what would it be?
It would be 450.
Something around 450. Is that clear? Yeah. It's not right now, according to this chart. Who knows this science stuff? But if it matched that trend, yeah, it would be around 450. I think that's our answer, right? Should be good enough. Oh, what's the answer here for number 16?
Should be less than 550.
Less than 550. Yeah. That's it. It's F. That's not too bad. Just understand the question. That's it. Great. Go and read question number 17 for us, please.
Suppose that whenever the CH4 concentration increases, a corresponding immediate increase in average global temperature occurs, and that whenever the CH4 concentration decreases, a corresponding immediate decrease in average global temperature occurs. Based on figure 2, which of the following graphs best presents a plot of average global temperatures over the past 11,000 years?
Oh, do you understand this question or no?
That was a lot.
That's a lot. Read it again if you need to. It's okay.
So CH4 concentration increases the corresponding increase over an average global temperature occurs. It decreases. Okay, I think I got it.
Yeah, what's the question asking us in your own words?
It's comparing if it increases or decreases with the concentration.
Well, it's not saying if it increases or decreases. It's saying let's suppose, whenever CH4 increases, a corresponding immediate increase in average global temperature occurs. Does that idea make sense? By the way, this is a hypothesis, right? Global warming is still a hypothesis here. But let's suppose that's the case. Okay. All right. Okay. Based on figure 2, which the following graph best represents the average global temperatures over the past 11,000 years. So do you see how CH4 concentration changes according to this graph? According to figure 2.
It like decreases and increases.
Decreases and increases, like a V shape. Do you see that? And so the question is, let's suppose, right, that whenever CH4 concentration increases, a corresponding immediate increase in average global temperature occurs. So if CH4 is decreasing then increasing, what's going to happen to global temperatures, supposing this is true, or that relationship is true?
It would kind of like be like the graph.
It'd be like the graph of CH4. Does that make sense? What's the answer here for 17?
B.
It's B. Done. But do you see the importance once again of properly digesting the question?
Yes.
That might be the biggest takeaway here. And I think, and you had to read it twice here, right? Because you read it the first time.
Yeah.
That's a lot of information. Okay, fine. It's kind of like that first read on the passages where it's like, I'm just orienting myself. That's it. And then you go back and you read even more closely and really understand the idea, digest the ideas on that second read. That's totally okay. I do it all the time. I'll read a question like, wait, what? Go back, digest, chew on it a little bit. Sentence by sentence, digest it again. You'll get it. But if you don't understand the question, if you just jump from that first read, like, you're wasting your time. Is that clear? Like, if you don't know what you're looking for, why look for anything? Right? Like, what are you doing? Just skip it. Just skip it. If you've read through it twice, 3 times, still don't understand it. But so far, I don't think there's one question we couldn't understand if we went back to it.
That is true.
Right? Which is an interesting idea as well. So part of it's just getting comfortable chewing on this kind of academic language, right? And that's why I do, practicing is so important. And the speed will naturally come as well if you get comfortable with this process. But you got to start untimed first. You just got to think about things clearly first. You got to boost your academic vocabulary. This is true for, for the reading section as well. You got to boost your academic vocabulary. Just practice basic reading comprehension skills. Practice your graph analysis skills. Just look at things the right way first. The speed will come. The speed will come naturally, and the accuracy will improve as well. Once you get in the score increase, you want to see untimed, then you add the timed element. Okay? But not until then. Right? Don't start with a bunch of timed. Like, just plowing through timed practice tests is not going to do it. Slow down first. Do it the right way, the way we're doing it. When you get in the score increase you want, add the timed element.
Okay.
All right. Go ahead and read question number 18 for us, please.
Based on figure 1, the average solar radiation intensity over the past 250,000 years was closest to which of the following?
Okay. We got back to figure 1. So the average solar radiation intensity for the past 250,000 years. All right. Do you understand this question here?
Yes.
Okay, great. Look at figure 1. Here we are. I got it on the screen share. Let's do the graph analysis thing. Okay. No title here. What's the y-axis going up and down?
The solar radiation and the concentration.
Yes. Yeah, and we're focused on the solar radiation here, so the y-axis on the left-hand side. Does that make sense? Great. What's the x-axis going left and right?
The thousands, the years.
Years ago. So it's got the whole spectrum here, right? We got 250,000 years ago to the present. Okay. There's a key, right? We see the key. Right? Solar radiation, dotted line, CH4 concentration, solid line, just like the other question. I think they're asking us for solar radiation, the average solar radiation.
Of
right?
250.
Over the past 250,000 years. So I know it's kind of like flying all over the place, but I can kind of eyeball where the average would be, right? Even though it's going up and down and up and down and up and down and up and down and up and down. Do you see roughly where the average would be?
Around like 460.
Yeah, maybe around. Well, the average, for solar
radiation.
480. Yeah, 460 is low.
It's like the middle.
Yeah, 480 is more in the middle, right? If I kind of cut across it. Do you see that? I'm kind of cutting right through the middle of all those peaks and valleys. So probably closer to 480. Why did you say 460 initially?
Oh, because I saw that it was the last thing there. But then when I looked at the average.
Yeah, they're asking for the average there. So that'd be kind of in the middle. So let's check the answers. I hope 480 is there. It is. And 18 is H. There it is. Done. Not too bad. right? But there you just got to have accurate graph analysis, and there's so much information there. Right? There's information on the CH4 levels that we don't need. There's information there about the concentrations of CH4 in the atmosphere we don't need. Right? Just focus on the information being asked about in the question. That's it. Go and read question number 19 for us, please.
One solar radiation cycle is the time between a maximum in the solar radiation intensity and the next maximum in the solar radiation intensity. According to Figure 1, the average length of a solar radiation cycle during the past 250,000 years was.
Okay. To what extent do you understand this question?
Well, it's asking the average length of the solar radiation cycle.
Yes. And then they define it here, right? It's the time between a maximum in the solar radiation intensity from one maximum to the next. Okay? All right. So we've got to figure out what's the average length of those radiation cycles from one maximum to the next. Okay, great. We understand it now. Let's go back to the chart. So we're talking about solar radiation. We're talking about the dotted line here. Is that clear? Okay. And so from when it hops from one to the next, one maximum to the next, how much time roughly is that? It's hard to eyeball exactly.
About like 50. Is that too much?
Well, let's are you on the screen share with me?
25. Yes.
Yeah. I would try to take 2 points, two maximums that are relatively close to the lines.
I see.
Right? There's a little art tag. Like if I'm picking these two, those are kind of in the middle, and honestly, that's going to be like visually just too much for me to process. But these two are close to the lines. You see that?
So it should be like about 20.
Yeah, that's like 20, right? Because each line represents, and you understand this is why you got to understand the units on the XY axis as well. Each line is representing 10,000 years. Does that make some sense?
Yes.
Okay. We know that because there's 5 units basically between the 250,000 and 200,000 years ago. So from this one to the next, there's roughly 2 lines, just a little bit more than 2 lines. So I'd say close to 20,000 years or a little bit over 20,000 years. Does that make sense?
Yes.
Okay, but take your time analyzing the chart there. Don't make any assumptions about it. Make sure you study the units. That's huge here. What's the answer for number 19?
Between 15,000 years and 35,000.
Yeah, they're very forgiving there, right? And if you're like, well, is it 22,000 or is it 20,000? I can't really tell. We've got it covered there with answer choice B. We've got it covered. Very forgiving. It's not less than 15,000. If you're iffy, but you could also test the answer choices there. I mean, like D is ridiculous. D and C are both silly. I mean, you could test them if you're iffy about it. But it's B. Go and read question number 20.
Which of the following statements best describes the primary effect of CH4 on Earth's climate?
Okay, they are really pushing this narrative here. Okay, great. So first of all, so CH4, that's methane, right? And I think they describe it earlier in the passage as a greenhouse gas. Oh, well, there we go. I see it there. Do you know this? I mean, without referencing the passage, do you know how CH4 is supposed to affect the Earth's climate? Do you have any idea? Or maybe not.
I don't know. I think it's either H or J.
Yeah. And if you're not sure about it, yeah, why H or J? I agree with you.
Because they're slightly similar.
That's interesting. If you're iffy, if you don't know the answer, we can just test the answer choices as well. Let's go through them together. Go ahead and read answer choice F.
CH4 gives off visible light to space, cooling Earth's climate.
Does that describe the primary effect of CH4 on Earth's climate?
It cools the climate.
That's what it's saying. Yeah. Does CH4 cool the Earth's climate?
Nope.
I don't think so. And we could go back to the passage as well. Read the first sentence of the passage.
Greenhouse gases such as methane warm the Earth's climate.
Right? So anything that's saying it's cooling it is probably not right. Does that make sense?
Yes.
Yeah. So we can get rid of F. Heck, we can get rid of H.
Oh.
Do you see that as well? Just knowing that, just by reading that first sentence in the passage. So here, I thought it might have been an outside information question, but they tell us right at the very beginning there of that passage. Yeah, CH4 warms the Earth's climate, right? In theory. All right. Go and read G for me.
CH4 gives off ultraviolet radiation to space, warming Earth's climate.
Does that describe the effect of CH4 on Earth's climate? At least it's warming it here. CH4.
No.
Yeah, I'm suspicious. Why? I'm very suspicious of that.
Well, I don't think ultraviolet radiation to space would warm the Earth's
And if
climate.
it's giving off radiation, like, wouldn't that mean like the temperature is going down or the energy is going down?
Yeah.
Right? It's kind of like that just doesn't make sense on a basic logical level. And I don't remember reading anything about it giving off ultraviolet radiation because I think that's an insane idea. Go ahead and read J.
CH4 absorbs heat that comes up from Earth's surface, warming Earth's climate.
Does that describe the primary effect of CH4 on Earth's climate?
Yep.
That sounds pretty good to me. Right? And that matches, I think, what we read in the passage as well. Pretty good, at least warming it. Yeah. All right. Great. Any questions about any of those questions?
Nope.
Okay. Was this helpful today, going over these questions the way we did them?
It was.
Good.
It was.
Good.
Yeah, I like having the practice. I feel like it's mainly just practice for me because they mostly just give you
It's all
almost
there.
the answers.
It's all there.
It's just in the chart.
It's all there, except for that ATP question again. But like you can still narrow some things down based on what you know. So it's about the just going through the right process. And let's talk about that process again. You know, for anybody watching the recording and they're prepping for the ACT, go through the ACT practice test. Do it untimed, right? Do it untimed first. Once you're getting the score increase you want, and this is true for really every section, then add the timed element and practice pacing there. Don't rush. You can kind of rush through reading the passage. Yes, you can. But don't rush through the questions. Read the questions carefully. Go through the right process. If you need to reread the questions, that's totally okay. And you'll finish in time as long as you don't get stuck on the toughest questions. I don't think we saw any, though, that I'm like, oh, that's a really brutal one. I wouldn't expect anybody to get it. Did we see any like that on here? I mean, they appear occasionally. But I would argue that for most students, you know, you probably want to end up taking, I call them freebies, where you just kind of like skip it with a smile. You're like, I'm not going to worry about that one. You know, I recommend between 4 and 5 on the science section in total. Okay. Between 4 and 5 that you're just like, man, I don't know what's asking me there. I can't find the answer. A minute's ticking by. I got to move on. You got to move on. You got to get to the end of the test or in the end of the section. So plan on skipping about 4 or 5. And you're not giving up on them. You can always come back to them if you have time. But it's always a bad investment of time to spend extra time on the toughest questions. It's always a bad investment of time because by definition, the toughest questions are the toughest ones to get right. Right? But if you're spending all this time on the toughest questions, then that's time either you're not spending on the easier and intermediate level questions you're likeliest to get, or that you don't even get to at all because you didn't finish the test. Does that make some sense?
Yes.
So that's what you got to focus on when you practice that timed element. So, Maddie, you've been awesome. This has been great. I hope this helps a lot of students prepping for the ACT. I might do another ACT science video coming. Who knows? We'll see. But
yeah, thank you.
But this has been good, and I think it's going to help some students. So, do you have any questions for me at the moment, Maddie?
No, this helped me a lot, actually.
All right, great. I'm so happy to help. I'm so happy to help. So, thanks everybody. Thanks Maddie for participating in this, and thanks everybody for watching. And look out for more ACT videos coming out eventually. Maybe I want to say soon, but I'm gonna be realistic. Coming out eventually. All right. Thanks so much, guys. Take care.